So here we have Buzzosonic. Basically, on the left here, we have a database to store and retrieve all the information for the samples that you measure. This, of course, I'm doing today. Today I'm doing the University of Maine. And then on this side is the physical properties here. And then the results from Buzzosonic here, the flexural frequency, for example, the outer plane Young's modulus, the shear modulus, and the Poisson's ratio. Then down here we'll see the results, the waveform, and the power spectrum will be shown in these two graphs here. And then this table here will show the peaks in the spectrum. And then on this side we've got the different shapes. So today we're just looking at a rectangular bar. That's the shape of the concrete specimen. Here are some of the other shapes that can be measured with Buzzosonic. Then, of course, we want to do the outer plane flexure today. And then the torsional frequencies. We'll measure those two because the outer plane flexure gives us a Young's modulus. The torsional frequency gives us a shear modulus. And then from those two, Buzzosonic will calculate Poisson's ratio. There are other modes of vibration that we can measure. So rather than go over all the different details here, I'll just do a quick test. So we've already put the information here for the 4-10 M2 concrete sample. We've got the length here, the width, the height, the mass, from which Buzzosonic calculated the bulk density. You can also just type that in if you know what the density is. And then on this side will the calculations. So okay, so down here, this little button here tells Buzzosonic that you want to measure the incoming sound. This little button here says, as soon as I measure the sound, I want to turn this little button off. And then on the left here, this is the signal coming into the microphone. And this is the volume of the microphone. And this little button here tells Buzzosonic this is a threshold setter, so when that volume exceeds this threshold setting, it will start to do the analysis. It'll capture the sound and then do the analysis. All these things, of course, can be changed and controlled with keyboard shortcuts. Or you can use, I have a remote control as well that you can use. So anyway, let's do a measurement then. So here we've got the concrete sample. Here we have the microphone. I don't know if you can see, but we've got two thin wires supporting the samples at 0.224 of the length from each end. So that's where the nodes are for flexure. So the sample is freely supported on thin wires. And this is the tool I use for larger samples. It's actually a xylophone mallet, but it works very well for concrete and refractories and grinding wheels. And later on I'll show you that underneath here I also have an automatic impulse tool that's controlled by Buzzosonic. So let's take the first measurement. There it is. Now I could type in a Poisson's ratio here so that Buzzosonic could do a quick calculation of the Young's modulus. Let's just do that for now. Let's put 0.2 in for now, and we can see that the Young's modulus is 27 gigapascals. But we'll take that off for now. Well, we'll leave that on. Sorry, I'll leave that on. Now that's the first sample that we've taken. Now if you want, you can repeat this several times and use the mean value. I'll just show that. If that looks good, we can add that to the stats with this plus key. So now we've added that one to the stats. If you want to look out how the previous one was, we can retrieve all this information. Okay, let's do one more. And there it is. So we've got three very quickly. They all look pretty much the same anyway. A little bit of difference, but not much. We can do one more or two more. So we've got 5 now. They're reasonably consistent. Okay, so now let's do the, let's try this now with the automatic impulse tool. So I'm going to go down to this one. It's the same sample, but I've just, I put in the dimensions and everything, but this time I'm going to use the automatic impulse tool. Here is the impulse tool. So let's try a measurement with that. And we'll add it to its statistics here. Do another one. I didn't like one of those, so let's just take another one. That one's a bit more noisy, so I'll take that one off. I was talking there, but anyway, it didn't really. We'll take that one off and just do another one. And there we have it. We get pretty much the same, 28, 28, 28, 29. So I can put a placeholder Poisson's ratio in just so as we can calculate the Young's modulus, 27.74 versus 27.78. That's pretty reasonable. I mean, the test is within 1%, generally speaking. Now let's set up for torsion. So I've set up for torsion, and basically I've got crossed wires. I don't know if you can see them, but there's a wire there and a wire here. So it's in a cross formation. And then the microphone is placed at 0.224 the length from the end, because that's the node for flexure. We want to eliminate that if we can. And I put it to one side because this is a torsional mode where the sample's twisting like this. So now all I need to do is tap it on the end there. But before we do that, and we'll change this now on the screen here to torsion. We can use the mouse to turn that on if we want. Now we need to remove the Poisson's ratio so that it does the calculation for Poisson's ratio. And here we have G is 12 gigapascals, Poisson's is 0.12. But as before, we can we can take averages. One more. Now, the other thing to note here, if we want, we could have offset this a little bit. You see, there's a bit of a sharp spike there. We can offset the waveform here to get a nicer curve. We could have also gone to, instead of 1 Hertz resolution, we could have gone to 10 and we'd have cleaned up the spectrum that way. But I think we'll leave it on 1 for now. So if we go back to all these, you see that first initial spike there. Looks like it's picking up some noise, so we'll just do this to all of them. doesn't really change the results that much anyway. But anyway, that's what we've got. So let's try this now with the automatic impulse tool. Don't need that anymore. Okay. I can put this a little bit closer actually. Oops, not quite as close as that. So the automatic impulse tool, like that. There we have it. Pretty much the same result. Very easy, very quick and reproducible.